Hello, welcome to the video. In this lesson, we're going to be looking at section 3.5, where we're going to be graphing linear equations in slope-intercept form. So, majority of us should be familiar with the general equation for slope-intercept form, which is what we have right here. Y is equal to mx plus b. What things that we need to know about this particular equation is what is our value of m and what is our value of b. M is going to be the slope of our graph, of our line, and b is going to be the location of our y-intercept. So throughout this lesson, we're going to take a look at different things that are going to allow us to determine what the slope is and what the y-intercept is for a particular linear equation. So for starters, let's take a look at the slope. So the value of m in with respect to the y is equal to mx plus b. Slope is the change in how the line is graphed, whether it's a positive line slope or a negative line slope. Here is how we can determine what that value is going to be for the slope of a particular line. So a fairly common saying for slope is you have to utilize what is called rise over run. Rise over run simply means that we are taking a look at the rise, which is the vertical change of our graph with respect to the line, and run is the horizontal change um, of our graph with respect to the line. So essentially, everything that's dealing with rise means we're either going to go up or we're going to go down. For run, we are either going to the right or we are going to the left. And there is a general equation that will allow us to identify what the slope is. Here is the equation that will help us determine what the ratio of our slope will be. It says it's y2 minus y1 divided by x2 minus x1. So where do we get those values? They come from the respected points that are on the line. So this coordinate here, which is called x1, y1, is a point that it's identified on the line. The second point here, which in this case is x2, y2, is the second point that is identified on the line. If you have 2 points that you can identify on the line, those 2 points will assist you in determining what the slope is. So here, y2 goes right here, whatever that value is, and y1 goes right here. Same idea, x2 will go right here, and x1 will go right here. You'll get values for those variables, and then you can go about and solve. So here it says describe the slope of each line, then find the slope. So describing the slope, there's actually uh, several different things, and actually let's take a look here at. Here are the different types of slopes. You can have a positive slope, negative slope, a slope of 0, and an undefined slope. So anytime you have a positive slope, that means that your value of m, the ratio, or is going to be a positive number. So if it's positive 2/3, it's a positive slope. If the slope is 3, it's a positive slope. A negative slope means that m is going to be a negative number. So like -1/2, -5, all of those things is going to be an indicator that your slope is a negative slope. Here, if you have a slope of 0, that means that if you use the slope formula and in the numerator you get 0 and it's being divided by some number that's not 0, then your slope is going to be 0. So because 0 divided by any number is going to be 0. An undefined slope means that m is going to be equal to some number on the top that's not 0, and it's going to be divided by 0 as well, because if you ever punched in your calculator any number divided by 0, you got some kind of in syntax error or domain error or something along those ends. That is an indicator that your slope is undefined. Another way of looking at it is if you have a slope of 0, the line is horizontal. If you have a undefined slope, the slope is vertical. So going back to looking at this, you know, you can find the slope of the value and then make the determination on describing the slope. So from here, we have 2 points. We have a point here and a point here. All right, it does not matter which one you consider as your x1, y1 or your x2, y2. You just have to make a choice and then go about using the formula. You will get the same answer whether you choose one way or another as your x1, y1. So normally, what I would suggest is the point on the left, make that your x1, y1, and the point on the right, x2, y2. And now we're just going to utilize this formula to get our slope. So m is going to be equal to 2 minus a -2 divided by 3 minus a -3. Both of these numerators and denominators have cross-line change of line situations. So now I get 4/6, which gets reduced to 2/3. Since 3 is positive, this is a positive slope. Looking at B, same thing. x1, y1, x2, y2. Looking at the slope of this, I'm going to have -1 minus 2 divided by 2 minus 0. -1 minus 2 is a -3. 2 minus 0 is 2. My slope is -3/2. And it is a negative slope because my slope value is a negative number. All right, so now looking here, it says the points represented by each table lie on a line. How can you find the slope of each line from the table? What is the slope of each line? So what you get to do is all you have to do, since they tell you that each point on here is in fact on the line. So you can choose any one of the points to help you find the slope. Okay, so I can choose these two, or I could choose these two in order to determine what my slope is. Okay, so Since it's a table, this gets represented as an ordered pair of 4 comma 20, and this one is 10 comma 8. You could have used the other ones, you'll get the same answer. I'm going to call this one my x1, y1. I'm going to call this one my x2, my y2. So utilizing the formula, I get 8 minus 20 over 10 minus 4. So 8 minus 20 is negative 12. 10 minus 4 is 6. And this gets reduced to a negative 2. In theory, this should work for every single one. So like, let's just say I used the other two ones, and let's just say that, okay, that's 7, 14, and this is 13, 2. Let's just, it should come out to be the same result. So in that one, it is what? 2 minus 14, all divided by 13 minus 7. This one gives me negative 12. This one gives me 6. I get negative 2. Yep, they're the same. So it just shows that it didn't matter which points we chose on the line. We knew we were going to get the same slope. All right, same thing goes for example B. All right, just pick two. All right, so if I pick this one and this one. So utilizing the slope formula, I'm going to have m is equal to negative 2, I'm sorry, it's positive 2 minus 2 divided by 1 minus a negative 1 plus plus. This equals 0 over 2. I get a slope of 0. Looking at C, I got m is going to be equal to, I'll just pick the top two. I got 0 minus a negative 3, all divided by negative 3 minus negative 3 plus plus. This turns into plus plus. That's 3 over 0. Since I have 0 in the denominator, this slope is undefined. All right, so again, we talked about this at the beginning of the notes. If we are looking at the equation for slope-intercept form, y is equal to mx plus b. Here is one of the indicators on how we can find certain values for these points. So like we said, b was the y-intercept, m was the slope. When you are graphing using slope-intercept form, the first thing you have to do is make sure that y is by itself. And so make sure, so I'll say y by itself. Then the second thing you're going to do is you're going to plot the y-intercept. The y-intercept is going to be located at whatever 0 comma b. So whatever the value of b is, you go to 0 comma b, and that's going to get you your slope. The third thing you're going to do is now you are going to demonstrate finding another point with respect to the slope and the y-intercept. So from here, you're going to use your rise over run. So in this particular instance, you're going to go down so many values, and then you're going to go to the right so many values to determine what your slope is. Once you've got 2 points, that's enough information to make a line. Take your straight edge and go from there. Okay, so from here, It says find the slope and y-intercept of the graph of each linear function. So let's take a look at A and say, all right, if we have to graph this, all right, so I put my graph over here for A. First off, is y by itself? The answer is yes. What is my y-intercept? My y-intercept comes from B. So since B in this case is -4, I know that my y-intercept is going to be at 0, comma 4. So 0, comma 4 is plotted right here. It's not 4, 0, comma -4. And then the next thing you're going to do is use that point for your slope. And so since the slope in this case is 3, you're actually going to write it as a fraction, and this is going to be 3/1. So what that means is from this point, you're going to go up 1, 2, 3. That shows vertical change. And then horizontal change, I'm going to go to the right one. So anytime you are looking at a number here that's positive, you are going to go up. If you're ever looking at a number in that numerator and it's negative, you are going to go down. Because my denominator was positive, I'm going to the right. If it was ever negative, it is going to go to the left. So keep that in mind. So I got this point right here. That helped me with the slope. So I got this point. I got this point. I have all my information to construct my line for, oops, let me do a better, I'll actually use a straight edge. So there is my straight edge with respect to the equation y is equal to 3x minus 4. And we were able to identify the slope, which was 3, positive 3, my y-intercept, which was a -4. Let's take a look at, oops, this one right here, C. -5x minus y is equal to -2. So right now, it is not solved for y. So we're going to have to do that. So let's go down here. Let me rewrite the problem. -5x minus y is equal to a -2. So if I were to add 5x to both sides, I would get now -y is equal to 5x minus 2. Because I have this -y, what I'm going to do is I'm going to divide everything by -1. So now this turns into positive y, this now turns into -5, and now this turns into positive 2. I just change the sign of every term in order to get my value of y to be positive. So in this particular situation, let's say if I were to graph it, it would look something like this. So my y-intercept would be at 0, comma 2. So it would be located right here. My slope is -5, which means I'm going to go down 1, 2, 3, 4, 5, and to the right one. The reason why I went to the right one is because if I were to write this as a fraction, it would be -5/1. My negative is in the numerator, so that means it went downward. 1 was positive, so that means it went to the right. So here is my 2 points. I have enough information to make my graph, and I connect the 2 lines. So this is the line y is equal to -5x plus 2. Y-intercept here, slope goes here. in this particular one, it says graph 2x plus y is equal to 2, and it says identify the x-intercepts. So this is kind of going back to what we looked at in 3.4. What I would do is if you wanted to find the x-intercept is first, let's set y to 0. So all you're going to do is take 2x plus 0 is equal to 2. And then I got 2x is equal to 2. Divide everything by 2. X is equal to 1. If it's asking us to graph it, we can graph it by saying, all right, there's a bunch of different points we can look at. I am going to solve for y, which is now y is equal to negative 2x to both sides. So now I got negative 2x plus 2. My y-intercept is here, and then my slope is down 2 to the right 1. And that makes sense. Going back to what we looked at, x equaling 1, 1 comma 0 is in fact the point that is located on the graph when we looked at slope. And connecting these two lines together, we are able to graph equation y is equal to negative 2x plus 2. And that is being able to graph linear equations in slope-intercept form. Hope this helps. Till next time.